All right, welcome and good day, everyone. Welcome to this OCP workshop on networking hardware. The subject that we're going to talk about today is advanced telemetry for NICs and switches, and it's going to work across a number of NOSs and orchestration tools. Hello, my name is David Isles. I'm a Senior Director at Mellanox Technologies, and I will be joined by a couple of gentlemen. First off will be Justin Betts, who is a TME over at Cumulus Networks. And then finishing up the presentation will be Alex Sorian, CEO at Netrist.ai, although you might know it more famously as xCloud Networks. So with that, I'd like to get into the presentation. First, let's talk a little bit about a big change in data center evolutions. One of the things you'll find is that data centers tend to be getting more and more simple, fewer and fewer protocols. And in fact, we find that the smarter our customers are, the fewer features they want running on their data center. The exception to that rule is around telemetry. The same guys that say, I want to get to 1 or 2 protocols on their data center network, those same guys want more telemetry features. They want more visibility into what's going on into their data center. Why? So why do we need good telemetry? So the very first reason is usually when something goes wrong in a data center, it's the network guy that gets blamed. And so the network guy wants to improve what they call their mean time to innocence. They want to improve how quickly they can prove it's not their fault, or if they have good telemetry, it'll help them do that, but it'll also help them get to resolution much faster. So they're able to kind of figure out exactly what went wrong. And for those CIOs out there, good telemetry lets you get more out of your network. And conversely, it also makes sure that you're getting the most out of your servers and storage. Because if you're having an oversubscribed network, it's a bad investment because you're not getting your money's worth out of your storage and your servers. So let's look a little bit about how people do this thing called telemetry. And you'd see that there's a lot of solutions out there for what we would call kind of normal telemetry. You know, data plane, looking at anomalies in data plane or in the control plane is a little bit of a gap. And that's what we're going to talk about today. A new feature that we call What Just Happened, and how it works with xCloud Networks, how it works with Cumulus Networks as well. So first off, let's look at a little bit about what just happened. And so what just happened kind of takes the normal network monitoring paradigm and puts it on its head. So if you look at the top part of the slide, this kind of shows the normal way of doing network monitoring, where you do streaming telemetry, or you do polling like SNMP, or use SFlow. But at the end of the day, what you're doing is you're collecting tons of kind of what we would call innocent data. You know, these are things where it's good to have a record of how many packets per second you're transmitting on given ports at any time of the day, but it really doesn't help you find out exactly what went wrong. In fact, what usually happens is when something goes wrong with the network, you, the network guy, have to spend the weekend sifting through a mountain of data trying to guess or extrapolate what the root cause of the events are. And so we came up with What Just Happened with the singular goal of kind of giving you your weekend back. The idea is that once you have all of this kind of good information, that's nice, but wouldn't it be great if the network told you exactly what went wrong? When you have dropped packets, when you have errors, tell you the root cause and remove that guesswork. So the way it works is every network out there will drop packets from time to time. And the most switches will do is increment a counter that says, I've dropped a bad packet because of X, Y, or Z. Like maybe it'll say, I've now dropped 10,000 packets because of bad VLAN. But you don't know from that counter is that because the switch is misconfigured, or the server's misconfigured, or the storage? All you know is that there's this error counter that just keeps incrementing every day or so. And then you try to recreate that problem, and sometimes it happens when you expect it to, and sometimes it doesn't. So the way What Just Happened works is when the switch needs to drop a packet, instead of just throwing it away, sending it off to bit heaven, before that happens, the switch records the important part of that packet that's getting discarded. It includes the packet header. It also puts on some very detailed kind of metadata. It puts a timestamp on there so you know when the packets are dropped. It puts a switch ID and a port ID so it knows where in your network the packet was dropped. It includes things like the port number, so you know what applications are being impacted. And the important part is this data is all streamed to a centralized database, and it's able to be used by things like free tools like Grafana and Kibana, but it also works with Cumulus's Netq, and it also works with xCloud. And the kinds of things that we can monitor, you'll see in a demo very soon, but whether you've got flaky cables, whether you've got routes that are sending traffic the wrong way, you have buffers that are just congestion events, whether you have security issues. So all of those things can be zeroed in on and will give you the exact packet that is causing trouble. And we can even do things when there aren't packets that are dropped, even when you get like past a certain level of congestion or a certain level of latency, bad load balancing. So we have prepared for you a number of demos, and the demos that we're going to talk about really use the topology that we're showing you here. What we're showing you is basically a number of switches, all Mellanox switches, but all of the switches each use a different network operating system. One of them uses Cumulus Linux, and for that, it'll show how that works well with Cumulus Netq monitoring. You'll see another switch with Onyx, another one running Microsoft Sonic, and another one just running just native Linux right on there. And so part of the demo, you'll see it working with Grafana. You'll see this what just happened working with Cumulus, and you'll see it working with xCloud. And one kind of important point to note is that this entire kind of what just happened database is going to be the same regardless of the types of operating systems you may have on the switches. And then one important point to note, and I'll just kind of bring back to this picture here, is what you don't see here, or it's hard to see, is there are servers here. And in many cases, the first hop of your network is not the switch. It's not your top of rack switch. The first hop is in your server. And so part of the demo is you'll see that these what just happened events can be generated by the NIC that's inside your server as well. So with that, I'd like to introduce Justin from Cumulus to talk about Netq.
Thanks, David, and greetings, everyone. Justin Betts here, TME with Cumulus Networks. And as a quick introduction to Cumulus Netq and being as concise as possible, Netq is the next generation network operation utility that's ultimately designed to make operating and managing your network easier. Netq was redesigned from the ground up from its original 1.x self to be a truly native cloud scale application. And how does it work? It's an agent-based streaming telemetry solution. A small lightweight agent is installed on any Linux device in the network. Naturally, this implies Cumulus Linux, but it's also supported on nearly all Linux systems. So installing it on all of the Linux servers in the environment gives you an extra layer of visibility. It gives you that host-based routing and network information, or even things like container visibility from Kubernetes clusters that can be integrated into your network view. But as it pertains to what just happened, we're extremely excited to be able to take advantage of this amount of visibility into packet drops and be able to correlate that to other network or operations activities. Many of us at Cumulus know what it's like to operate in network. And one of the most frustrating and difficult problems to detect and debug in the network are those intermittent issues and application performance issues. Quite often, these problem sets are caused by network packet drops. And confirming that's the case, and then why and how, is extremely difficult. And it gets even more difficult as speeds and feeds increase. Packet captures are usually the go-to tool, but beyond 1 or 10 gigs, port speeds, it's almost impossible to use span and off-the-shelf tools to capture and analyze traffic for extended periods of time. And as of now, network engineers have very limited options. Like David said, we can do things like watch hardware counters, but there's low resolution there and no flow information available. You're sort of left to guess and check and use the process of elimination. And you can use things like IPFix or the flow family of monitoring tools, but sample data has its own problems to trust and doesn't always help us confirm if packets are actually lost or dropped. And then you're left with other tap and span aggregation solutions, but they tend to be costly and don't scale that well. But with the Netq and Mellanox, what just happened, we can catch these packet drops in real time, and we can analyze the network drops fabric-wide as well, alleviating a lot of these node by node and box by box efforts. And then there's built-in support. We don't need any dedicated ports or extra gear. And part of what Netq does, as you'd expect all of your network operations tools to do, is provide you with easy access to view and search and sort through large amounts of data. And this is the case with what just happened. This can lead to quite the amount of needle and haystack, but Netq gives you a single pane view into those drops for the entire network, integrated into the workbench and alongside of all of the other useful normalized data. What just happened drops are categorized by type and are easily searchable and sortable by hostname or IP addresses and ports. So if you're looking for something particular, it's really easy to find. And again, the extremely exciting part of Netq's integration with Mellanox, what just happened, is the ability to correlate these network drops with other diagnostic features that are unique to Netq. The best example of this is what we've done with the Necu Trace feature. A Necu Trace is like a trace route, but in much more depth. It allows you to discover all the paths between 2 points in the network through the fabric, including overlays, and then also simultaneously check those relevant paths for errors or problems. This trace feature is available in both the GUI and on the CLI. And up here are some examples of the output it gives you there, showing the different paths available. Yep, so with our most recent Netq release that includes what just happened integration, we've added the ability to correlate what just happened drops that stream into Netq with the Necu Trace diagnostics. And they let you know about the packet drops reported by what just happened that are pertinent to the endpoints that you're tracing between. So as an example quick, let's imagine you're an operator looking into a problem report for communication problem between two servers. As you're about to discover, there's an issue on one of the leaf switches that's dropping packets between those two specific IP addresses. But let's see what uncovering this problem would look like if you were to start your troubleshooting with a Necu Trace. When you're using a Mellanox Spectrum platform with Netq and have what just happened enabled, discovering a problem like this can be a single step. A Necu Trace is a normal troubleshooter's first step, if for nothing else, telling you the exact paths that the problem flows will take. But here you also get all of Netq's analytics and correlations for free. Like we saw previously, we can detect config issues like an MTU mismatch between two sides, but now with the ability to correlate with what just happened drops, whole sets of problems like routing drops or ACL drops that occur in the data path are relevant and irrelevant to the endpoints can be instantly detected and brought to your attention via this trace. So in this example, we performed a Necu Trace for the two servers that are experiencing the problem. And like I said, normally we do this as a first step, so we can quickly discover all the ingress and egress ports and VLANs. If there's a problem or if there is an overlay like VXLAN, we can see those VNIs as well. But now with what just happened, the Necu Trace can also search for those IP addresses or endpoints in the what just happened drops for each link and for each path that it discovers, and then maps it out for you. So what we see here is we've got a routing problem on leaf 01. It looks like we've got a null route to this destination, so that's something we'll certainly have to fix. We're looking forward to continuing to develop Netq and create new levels of insight and richness of view with the capabilities provided with what just happened. Netq will continue to add support for more drop reasons and drop type support, which will extend our correlation capabilities. We're also looking into extending what just happened into our threshold crossing alert features, so you can do the types of things like implement baselines, where you can establish thresholds that are worthy of further investigation. And then as we dream into the future for what we might be able to do with this drop data are things like application identification. There are ideas around trying to perform some additional analysis on packets and proactively identify issues with critical applications or endpoints. And then we're also working on ways to integrate or overlay what just happened drops with a Netq's topology view. So Cumulus is thrilled to work with Mellanox and consume this truly unique feature in a way that we redesigned and really imagined Netq to be used for. So with that, I'll hand it over to Alex, CEO of Netris.ai.
Hi, everyone. Thanks, Justin. I'm Alex Sorian, CEO and co-founder of xCloud Networks, which is currently being rebranded into Netris.ai. So thanks for coming up and for watching this presentation online. Netris.ai is the NetOps, a software that makes network operations safe and simple. Netris.ai provides cloud-like user experience by exposing simple and intuitive interface as a GUI and API, optimized to be used by networking and non-networking people alike. Just like in a cloud, our users define model of desired network behaviors then Netq AI turns that model into a validated operational configuration running on the actual hardware. So automated configuration saves from misconfigurations on the network. But our software has no control and no visibility of anything outside the network. So what if something is misconfigured on one of the servers or on upstream router of the ISP side or VPN side or SD-WAN side? What if there's a misconfigured VLAN ID or MTU size or even new version of application has just started listening some new TCP ports, but your security policy or your load balancer configuration is not on the same page with the application? So networks that are running Mellanox hardware will be able to, benefit from advanced telemetry functions that Mellanox ASICs provide through their what just happened technology. So every time for whatever reason a network packet is dropped, Mellanox ASIC sends some data, then we are able to compare that data with user-defined network model and come up with actionable insights. Say things like, hey, your host is sending packets mistakenly tagged with the VLAN X, but the right VLAN ID should be VLAN Z. Or like, hey, your ISP is sending some of the packets mistakenly with a larger size than 1500 bytes. So you probably want to talk to your ISP and sort it out. But enough talking. There's 3 great demos that Mellanox, Cumulus, and us created. Let's look at these demos.
Cumulus Networks is pleased to announce what just happened support with Cumulus Linux 4.x and Netq 2.4. The unique combination of rich telemetry data from Netq in combination with Mellanox what just happened drop data collected from the entire network brings a new level of analysis and correlation to network operators and troubleshooters. Dropped packet information is available in an aggregated and centralized view available from the Netq workbench. From here, you can search and sort to quickly identify packet drops by their type, or reason, or IP address, or port. When troubleshooting, knowing whether or not you find packet drops on the network for the application or service that's affected, then also knowing exactly why it's dropped is incredibly valuable information for root cause analysis. Likewise, the lack of finding packets being dropped on the network is also an extremely useful data point. In nearly all cases, you'll find this dropped packet information valuable, and it's at your fingertips available for you to know instantly. And like nearly all other data in Netq, this information is also available on the CLI if that's your comfort zone. We can easily view what just happened drops by type and use familiar shell constructs to help find what you're looking for, or even include time domains. But the most exciting aspects of what just happened drop data, when combined with Netq's analytics, are currently illustrated through the enhanced Necu Trace feature. Netq's trace feature is an enhanced trace route. By knowing so much about the network and control plane from every node via the streaming telemetry agents, Netq discovers all of the possible paths through the network, including the VXLAN overlay, and displays them for you. So in addition to simple path discovery, Netq runs robust diagnostic checks for each link and for each node in the path. Now we can correlate what just happened drops that are relevant to the Necu trace requested. In our example here, we've asked Netq to perform a path trace between 2 servers on our network. Let's trace the path between 10.2.4.104 from 10.2.4.102. These are 2 servers in this demo environment. So you can see Netq reports its path discovery results, but it also includes the output of the correlated diagnostics. In our case, not only do we have an MTU mismatch on a link in the path, but Netq looked through all of the dropped packet data for IP addresses that are relevant to this trace and relevant to the links and nodes where these drops were seen. So with just one command and powerful analytics, with the help of Mellanox What Just Happened, we're able to diagnose the root cause here and see that we have an MTU mismatch problem on a link that affects only some of the equal cost paths. Cumulus is hard at work continuing to develop Netq, and we're looking forward to continued partnership with Mellanox to bring more and more innovative data plane anomaly reporting and analytics to the industry through Cumulus Netq.
xCloud Networks is pleased to announce integration of What Just Happened technology. xCloud is a software that runs your network. Combination of xCloud and Mellanox What Just Happened technology takes network troubleshooting to the next level. xCloud operated networks are free from network misconfiguration risks, but what if something goes wrong outside the scope of xCloud operated area that can degrade operation of final service and affect end-user experience? By leveraging Mellanox What Just Happened data just from network switches, our analysis module is able to find root causes of failures that are even outside xCloud operated network area and so provide customer with actionable insights. So here we have a couple of switches and servers, and we have some services configured VPC 10 and VPC 100. Here's What Just Happened dashboard when it's clean. And this is a user server which is physically connected to the network, but it's experiencing some network troubles. And our software has no visibility into server-side configuration, but thanks to Mellanox What Just Happened data collected basically from network switch and not from the server, and with analytics module that we have, we can come up with this information, like packets are dropped due to VLAN ID mismatch affecting service VPC 10, and the reason is that this host with this IP and this MAC attached to this port is sending packets with a VLAN ID tag 222, while VPC service configuration is expecting packets to be tagged VLAN 10. Let's look to another case. So this server generally operates well unless it is trying to send larger packets. So what just happened? And we see that packets are dropped on this switch due to MTU mismatch affecting service VPC 100 with reason wrong MTU configured on host with this IP, with this MAC attached to totally different switch on this port. Let's see if this is actually helpful. I'm changing MTU configuration as it was suggested. And let's see if it works. It works. Was this helpful? Besides that, we show here just raw logs, and of course we let users to apply filters and stuff, just regular things. And like any other data inside xCloud database, we also can stream everything to third-party tools, and so you can visualize the data using your favorite tool, for example, Kibana. And we're looking forward to continued partnership with Mellanox for bringing more and more innovative networking products, because our mission at xCloud Networks is making network operations safe and simple.
In our demo network, we have 4 Mellanox Spectrum switches running 3 different network operating systems: Mellanox Onyx, Microsoft Sonic, and Dent, a native Linux operating system promoted by Amazon. We also have a number of servers with Mellanox ConnectX network interface cards. All of the network devices, the Mellanox NICs, and switches are using what just happened to identify network issues and to stream critical events along with the details from the actual packet headers. Let's see what just happened in action. We'll start with our Grafana dashboard and see some what just happened events. All our network elements are streaming what just happened events to an influx database, while the events are presented by this Grafana dashboard. The first and very important events are the Layer 1 events that what just happened identified. If there are cables or transceivers which were unplugged, ports were toggled, or CRC errors, what just happened will let us know about it. We can sort the events by ports admin states, down reasons, etc. We can also check the distribution pie chart to identify Layer 1 issues on our network and can see which events happen more often than others. Now, let's look beyond Layer 1. You can see that our network is clean and working properly. But not anymore. Our Sonic switch is dropping packets. Let's understand what we are seeing here. One of the servers is sending a DNS request to Google 8888, but no results. What just happened shows us what's going on with all the DNS requests. We can see the packet's header and drop information in a way that is very easy to understand. The DNS request packets are dropped because the TTL is too small to exit the fabric and get to the outside DNS server. Maybe we have a routing loop? We can simply check if this server has connectivity to our border leaf switch by pinging that switch's loopback IP address. Oh, now our DENT switch is dropping packets. What just happened shows that our DENT switch is dropping the ICMP packets from the server due to a black hole route. It looks like there are even more issues with routing in our fabric. Maybe we should check the routing protocols? Okay, what just happened helped us to discover that we have some routing issues in our fabric. We will fix the routing and we will be good to go. But wait, what just happened? We can see in Grafana that our Onyx switch is now dropping packets. What is this new problem? We can see that a server tried to send UDP packets to another host, and the UDP packets were dropped due to an MTU mismatch. It looks like we have an MTU misconfiguration somewhere in our fabric. Lucky for us, the what just happened detailed information tells us exactly which port and which switch is misconfigured. We can see it's port 19 on our Onyx switch, which has the MTU misconfiguration. It's so easy to find issues with what just happened. Another issue, our server is dropping packets, which we only know because the ConnectX NIC has what just happened enabled. We can see that a server is trying to ping a neighboring server, and the NIC is dropping the packets due to ingress VLAN filtering. It looks like the host guys probably forgot to configure their NIC to accept tagged packets from the switch. What would we do if we didn't have what just happened in our network? It would probably take us hours of blaming each other and then days to debug and identify all the problems in our network, especially with all the different network operating systems and even packets dropped inside the server. Let's review again the what just happened events we saw in our fabric, both from the switches as well as the NICs. Our Onyx switch is dropping packets with larger MTU. Port 19 has an MTU misconfiguration that needs to be corrected. Our Sonic switch is dropping packets since the packet's TTL expired. Maybe we should look for a routing loop in the fabric. Our DENT switch is dropping packets since it has no route to the remote IP. We probably should check out routing protocols. And the last one, packets are dropped inside the server, and our ConnectX NIC was able to tell us about it. Our ConnectX NIC is dropping packets because it has no VLAN configured. Let's check the aggregated events dashboard of our environment. Everything is aggregated in one place with different categories to allow us to see the distribution of the what just happened events. Different switches, network operating systems, NICs, servers, all kinds of issues that we face in our fabric. And one what just happened feature to tell us all about it.
Wow, those were some very compelling demos of this technology. So with that, at the end here, you may have some questions. And unfortunately, I don't think we have time to deal with that right now, but you are welcome to reach out to myself, David Isles, or Alex, or Justin. I've included our email addresses here so that you can reach out, send emails to us. We'd be happy to answer any questions you have about our frameworks, about what just happened, about our solutions, or any of this kind of advanced telemetry technology.